Hello everyone. This video we are going to discuss about chemical engineering GATE 2019 process instrumentation dynamics and control questions with solution. GATE 2019 question paper and answer key link is available in my description box. You can download it. Question number 30. This problem from multi-capacity control system. Consider two non-interacting tank in series as shown in figure. The figure is given in the problem. Water enters tank 1 at q centimeter cube per second. So this is the inlet of tank 1 and it drained down to tank 2 by gravity at a rate k into root of h1 centimeter cube per second. So this is also the flow rate. This value assigned is in the name of q1. Okay. So this is also the flow rate. So tank 2 by gravity at a rate of k into root of h2. Are you clear? Okay. This is the outlet of tank 2. So this is also assigned in the name of q2. q2 also flow rate. What about the h1 and h2? h1 and h2 is also height of the tank 1 and tank 2. Okay, height or level. Drain valve constant k is equal to 4 centimeter power 2.5 per second. Cross section area of both the tank the same. Capital A1 is equal to A2 is equal to 28 centimeter square. At a steady state operation, the water inlet flow rate is QSS is equal to 16 centimeter cube per second. Transfer function relating the deviation variable H2 bar to flow rate Q bar. So the H2 bar is this is deviation variable. So the height or level. So in terms of centimeter, the flow rate deviation variable q bar. So this is in terms of centimeter cube per second. So this is relation h2 bar divided by q bar. So answer for this problem is option A. I am going to explain how is it. So we have the two tank. So first take tank 1. So tank 1. So here the inlet is a Q, outlet is a Q1. Okay, this is the inlet and outlet. So height of the tank is a H1, area of the tank is a A1. Okay, so here first we should write the material balance. Inlet minus outlet is equal to rate of accumulation. Under unsteady state condition we should take rate of accumulation. So for this tank, inlet is a Q, outlet is a Q1. So what about the rate of accumulation? So area is a constant, we should take the outside A1. So here variable is the height or level dH1 divided by dt, that is rate of accumulation. This is equation number 1. So the flow rate is directly proportional to the level. So this is the relation. Q1 is equal to H1 by R1. From these, what about the height value? H1 is equal to Q1 into R1. This is equation number 2. So substitute equation 2 in equation 1. What is this value? Q minus Q1 is equal to A1 R1 dQ1 divided by dt. Why? Because the R1 is a resistance of the tank 1. This is unsteady state relation. Whereas steady state relation, so the similarly inlet minus outlet is equal to 0. Why? Because under steady state rate of accumulation is equal to 0. So Qs minus Q1s is equal to 0. This is the fourth equation. So next step we have to introduce deviation variable. Q minus Qs is equal to Q bar. Q1 minus Q1s is equal to Q1 bar. This is equation number 5. Subtract equation 3 from equation 4. So 3 from equation 4. So what is the third equation? Q minus Q1 is equal to A1 R1 dQ1 divided by dt. Fourth equation, Qs minus Q1s is equal to 0. This is the next step. So here Q minus Qs minus of Q1 minus Q1s is equal to A1 R1 dQ1 divided by dt. So this is the sixth expression. So now substitute fifth expression in sixth expression. What is the fifth expression? Fifth expression is a deviation variable. Substitute fifth in 6. So Q bar minus Q1 bar is equal to A1 R1 dQ1 bar divided by dt. So this is the seventh expression. Take Laplace transform. Next step. So Q bar goes to Q bar of S. Q1 bar goes to Q1 bar of S. So right hand side A1 R1 dQ1 bar divided by dt. Laplace transform, that is Q1 bar of S into S. So rearrange this expression. From this we are going to find out Q1 bar of S divided by Q bar of S. This is the first order system. 1 by tau 1 S plus 1. So this is 8th expression. For this expression A1 R1 is equal to tau 1. A1 is the area of the tank 1. R1 is the resistance of tank 1. A1 R1 we should take, that is tau 1 time constant. So the similarly lower tank or tank 2. So tank 2 condition, the inlet is here the Q1, outlet is Q2. Okay. So here what is the H2? H2 is height, A2 is area. So this is the second tank or lower tank. So here area, both tanks are similar. This is a given data, is right? A1 and A2s are both are same. So here we should follow the same procedure. The step number 1. So we should write the material balance. Q1 minus Q2 is equal to rate of accumulation at a unsteady state condition. So here inlet is a Q1, outlet is a Q2, rate of accumulation A2 into dH2 divided by dt. So here similarly the flow rate and height relation, Q2 is equal to H2 divided by R2. From this what is the H2? H2 is equal to Q2 into R2. Substitute H2, that is 11th expression in 9th expression. So what is the 9th expression? Q1 minus Q2 is equal to A2 R2 dQ2 divided by dt. This is unsteady state condition. Similarly, steady state condition. Q1s minus Q2s is equal to 0. Already I said. Rate of accumulation is equal to 0 at a steady state condition. So we should take 0. So now the equation 12 minus 13. Subtract equation 12 from 13. So here Q1 minus Q1s minus of Q2 minus Q2s, that is equal to A2 R2 dQ2 by dt. So this is the 14th expression. Next step, introduce deviation variable. Unsteady state minus steady state, we should take Q1 bar. So similarly Q2 minus Q2s is equal to Q2 bar. So A2 R2 here, that is a tau 2. This is a 15th expression. Substitute 15 in 14. So finally we get Q1 bar minus Q2 bar is equal to tau 2 into dQ2 bar divided by dt. This is 16th expression. Next step, we should take Laplace transform. Q1 bar goes to Q1 bar of S, Q2 bar goes to Q2 bar of S. So here right hand side this is tau 2 S, Q2 bar of S. So here the Laplace transform of dQ2 bar divided by dt is equal to S into Q2 bar of S. So from this rearrange the expression, finally we get Q2 bar of S divided by Q1 bar of S is equal to here, that is equal to 1 by tau 2s plus 1, that is 17th expression. From equation 8 and 17, 8th expression for tank 1, 17th expression for tank 2. From that the overall transfer function q2 bar of s divided by q bar of s, that is equal to 1 by tau 1 s plus 1 into tau 2 s plus 1. So this is multi-capacity control system. So here the h2 bar of s, how it is come this value? So this is the relation flow rate and height. So here q2 is equal to h2 by r2, clear? So from this q2 bar of s is equal to h2 bar of s divided by r2. Okay, so the replace the q2 bar, take h2 bar of s divided by r2, denominator q bar of s, that is equal to 1 by tau 1 s plus 1 into tau 2 s plus 1. From this h2 bar of s divided by q bar of s is equal to r2 by tau 1 s plus 1 into tau 2 s plus 1. So this is the 18th expression. So here at a steady state we have some value. Already we have introduced the notation q2 and q1. So the q2 is equal to k into root of h2, q1 is equal to k into root of h1. At a steady state mean we notation is a s. Okay, s denoted as a steady state. From the equation 4 and 13. So equation 4 and 13, the qs minus q1, what is the equation? Qs minus q1s is equal to 0. Refer the previous one. So 13th expression, q1s minus q2s is equal to 0. From that qs is equal to q1s, q1s is equal to q2s. So they compare these two. So finally we get qs is equal to q1s is equal to q2s. Okay. So given data, qs is equal to 16 centimeter cube per second. What about the q1s and q2s? All are same, is right? We should take q1s and q2s is equal to 16 centimeter cube per second. Now we have q1 and q2s value. So take this value, q1s is equal to k into root of h1s, q2s is equal to k into root of h2s. Substitute the value, find out h2s value. So here the k value is also constant value given. We should take that value. So finally we get h2s is equal to 16 centimeter. What about the h1s? The same value, that is also 16 centimeter. So we know the relation flow rate and height. So q is equal to h by r. So here r is equal to 1 by dq by dh. So this is the differentiation of this equation. Finally we get capital R is equal to 1 by dq by dh. What about the R2 here? R2 is equal to 1 by dq2 by dh2. Here what is the q2? Q2 already we have, right? The assigned value k into root of h2. So here substitute, differentiate with respect to h2. The finally we get k is a constant, is right? Take outside 1 divided by d into root of h2 by dh2. So d into root of h2 mean h2 power 1 by 2, n into x power n minus 1, 1 by 2 into 1 by root of h2. This is the answer, differentiation. So substitute h2 here. Already this is calculated value, h2. So here substitute, finally we get a resistance, that is R2 is equal to 2. Similarly, what is R1? The same procedure, we should take R1 values also 2. So we know the formula, time constant, that is tau 1 is equal to A1 R1, tau 2 is equal to A2 R2. Here A1, A2 both are same. So finally we get the calculated value, R1 and R2 is also same. Tau 1 is equal to 56 again, tau 2 is equal also 56 again. So we have overall transfer function h2 bar of s by q bar of s. This expression R2 values are 2. Here tau 1s plus 1 into tau 2s plus 1, 56s plus 1 into 56x plus 1. So this is 2 divided by 56s plus 1 whole square. Okay. So this is option A. So this is the answer for this problem. For further related videos, you can like, share and subscribe my channel. Thank you.